Hi guys, today we're gonna talk about the modern periodic table. And if you stay with me to the end of this video, you'll find out the reason of placing element in a group and the reason of placing element in a row or period. For example, why lithium and sodium are in the same group or potassium and calcium are in the same row. And you'll find out that why the periodic table has several colors and each color means what. It's time to reveal the secrets of periodic table. Let's do that.
In 19th century, after more than 60 elements discovered, scientists decided to give order to the elements. They agreed to arrange elements based on their atomic mass, and Mendeleev designed a table for elements based on mass of atoms increasing. But after subatomic particles discovered, another scientist in name of van den Broek suggested a rearrangement of the periodic table according to atomic number of protons of an atom, and modern periodic table arose. Periodic table is made up of 18 columns and 7 rows, moreover 2 inner columns, and overall 118 elements. Column is called group and row is called period. In fact, elements in the same group have same valence electrons, and as electrons specify chemical properties, so elements in the same group are similar in chemical properties. And elements in same horizontal row or period have the same number of electron shells. For example, all elements in period number 3, their last electrons are in shell number 3, and each next element in a period has one more proton or atomic number. As periodic table is arranged based on atomic number. If you don't know or have forgotten how to achieve valence electron, I recommend to watch our video about this subject to learn it so easy. For example, all the elements in group number 1 end up with S1 when we write their electron configuration. In addition to electron configuration, periodic table is made up of 4 blocks, S, P, D, F. S block that, as I said, is consisted of S1 and S2. Group 1 that its elements end up with S1 is called alkali metal. The alkali metals are all shiny, soft, highly reactive. Group number 2 which its elements ends up with S2 is called alkaline earth metal. They are all silver colored and soft, and have relatively low densities, melting points, and boiling points. P block are the last 6 group of periodic table, as P subs Hell can have 6 electrons, so the numbers of its group are 6. For example, when we write B electron configuration as its atomic number is 5, that would become 1s2 2s2 2p1, as we see B ends up with p1. In this way next groups ends up with p2, p3, p4, p5, p6. P5 group is called halogen and p6 is called noble gases. The only element in P block that doesn't end up with P is helium, as it has only 2 electron and can't reach to P subs Hell, but because its behavior is exactly like noble gases, helium classified in group 18th. Note, elements in any of groups 1, 2, S block, and 13 through 18, P block, are called representative element. D block elements. D subs Hell can put 10 electrons in its orbitals. There are 10 groups for D block elements. These elements are called transition metals, as implied by the name. All transition metals are metals and thus conductors of electricity. In general, transition metals possess a high density and high melting points and boiling points. And finally, F block elements. They are consisted of 2 groups that each group has 14 elements, as F subs Hell has 14 electrons. First group is named lanthanide because its elements are similar to lanthanum, and their atomic number are from 58 to 71. And second group of F block is named actinide, as the elements are similar to actinium. Their atomic number are from 90 to 103. All of the elements of F block are metal. Note, elements that follow uranium in the periodic table have atomic number more than 93, are called transuranic elements, and they are so radioactive elements. Now let's highlight phases of elements in periodic table. In standard condition, of the 118 elements, 11 elements are gaseous, which they are hydrogen, nitrogen, oxygen, fluorine, chlorine, and noble gases, helium, neon, argon, krypton, xenon and radon, are gases at standard temperature and pressure. 2 elements are liquid, that they are bromine and mercury, and the rest are solid. Classification of elements in terms of being metal, semi-metal and non-metal. 17 elements are generally classified as nonmetals. A nonmetal is a chemical element that mostly lacks metallic attributes. Physically, nonmetals tend to be highly volatile, easily vaporized, have low elasticity, and are good insulators of heat and electricity. Most are gases: hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon and radon. One is a liquid, bromine, and a few are solids: carbon, phosphorus, sulfur, selenium, and iodine. Then semimetals. Elements, typical metalloids or semimetals, have a metallic appearance, but they are brittle and only fair conductors of electricity. Chemically, they behave mostly as nonmetals. The 6 commonly recognized semimetals are boron, silicon, germanium, arsenic, antimony, and tellurium. And the rest of elements are metal. Now let's see what are the numbers around elements in periodic table. Usually the smaller number represents atomic number, that it is number of proton of that atom, and bigger number shows average atomic mass. Atomic mass is summation proton and neutron, and in average mode, we should consider abundance percentage of atoms' isotopes. In this video we found a general mentality about the periodic table. In the next video we will talk about how to find the position of an element in the periodic table using its atomic number.